Hello. This time I'm going to explain the precalculus homework from section 5.4, which is about the logarithmic function. There are about 24 problems to go. Okay, so number 1. So select the correct choice that completes the sentence below. So y is equal to natural log of x. And this can be rewritten as, so natural log is same thing as log of base e of x. And this can be written as e to the power of y is equal to x. Okay, so in general, log of base b of x is equal to y is same thing as b to the power of y is equal to x. Okay. Number 2. The question is about the domain of the log function. So let's say y is equal to log of base 5 of x plus 1. The domain for the log function is all positive numbers only. So base doesn't matter, but the domain must be all positive numbers. So domain is all the real numbers such that the inside the log function must be positive. So this is same thing as all number greater than -1. So it's going to be all real number satisfying this inequality. In the interval notation, this is same thing as -1 through infinity. By the way, if you graph this function, it's going to be looks like this. So at the border of the domain, there's going to be a vertical asymptote. And when x is 0, y becomes 0. And when x is equal to 4, which makes the interior number 5, y value is equal to 1. And the graph going to be an increasing function like this. Okay, number 3. Find the exact value of log of base 8 of 512. When you see 512, we can rewrite that one as 2 to the power of 9s. Or 2 to the power of 9 is same thing as 2 cubed to the cube. So it's going to be log of base 8 of 8 cubed. And this is actually equal to 3. Okay. So we are using the fact that log of base b of b to the power of x is equal to x, because it's by definition, the log is inverse to the exponential function. So log of base b of b to the x is always equal to x. Yeah, please memorize 2 to the power of 1 through 2 to the power of 10, so you can solve this one quickly. Okay, move on to next problem. Okay, now this is like a rewrite exponential expression in log. So this is equivalent to, so put both sides of the expression in log of base 4. So when you have two numbers equal to each other, and if they are positive, you can put both sides of the equation into log. And the right-hand side become 2. Okay, so 4 squared is 16. Same problem, number 5. We have 2.9 is equal to 4 to the power of x. So using a log expression, this is equivalent to say log of base 4 of 2.9 is equal to x. Again, this is like a reverse problem. Log of base 7 of 2401 is equal to 4. This can be written as 7 to the 4th is equal to 2401. The idea is actually you want to put both sides of the equation on top of 7 like this. And because exponent and log is inverse to each other, b to the power of log of base b of x is always equal to x. So using this fact, the left-hand side, b to the power of log of base b of whatever is equal to 2401. Okay. Well, next problem is almost identical. 4 is replaced by x. So number 7, this is just x. So this is equal to x. And so this is equal to x. Number 8. Evaluate expression. So I need to find the exact value for this one. Log of base 2 of 1. So this means 2 to the what power gives us 1? And the answer is 2 to the power of 0 is equal to 1. So this is equal to 0. Okay. Next one, log of base 8 of 64. So 64 is 8 to what power? And we know that this is equal to 8 squared, so it is equal to 2. Next one, log of base 2 to the 1 over 32. So what is this? 32 is 2 to the power of 5, but because it is reciprocal, it is actually 2 to the power of negative 5. So this is equal to negative 5. Next one is a bit harder. So log of base 1/2 of 128. Now, we know that 2 to the power of 7 is equal to 128. This is something to memorize. Now, we have a base 1/2 instead of 2. So we had to change this expression slightly. So kind of take a reciprocal of both sides of the equation. So 1 over 2 to the 7 is equal to 1 over 128. So this means 1/2 to the 7th is equal to 1 over 128, right? So we want to have 128. So we're going to take kind of reciprocal again. And that's going to give us 128. So this is equal to 1/2 to the power of 7 gives 1 over 128. So we're going to flip it. And that is equal to negative 7. Okay, next one, number 12. So now log of base 4 of square root of 4. Now, square root means this is same thing as 4 to the power of 1/2. So this is equal to 1/2. Okay, log of square root of 2 to the of 8. So again, we want to know what is 8? What is square root of 2 to the what power gives us 8? We know that 8 is 2 cubed. Okay, and 2 is same thing as square root of 2 squared. So that is equal to log of base square root of 2 of square root of 2 to the power of 6. So the answer is 6. Now, if you know the change of base formula, then this can be solved probably more easily, like this. So if you know the change of base formula, which is log of base b of m, can be re-expressed as log of base any c m over log of base c of b. So direct comparison of square root of 2 and 8 is kind of hard. So I'm going to use base 2 to connect these two numbers. So it's going to be log of base 2 of 8 over log of base 2 of square root of 2. The numerator become 3, denominator become 1/2. So multiply top and bottom by 2, we're going to get 6. Number 14, it's ln to the power of, ln to the fifth root of e. This is same thing as ln of e to the power of 1/5. And since ln means log of base e, this is equal to 1/5. Okay, number 15. Find the domain of the log function. So domain of the log function, the inside of the log function must be positive. So basically, x plus 2 must be positive. So x is greater than -2. In the interval notation, it's -2 through infinity. Number 16, again, I need to find the domain of the log function. So that means x to the power of 9 must be positive. And the graph of the ninth power of the polynomial power function, it looks like this. And this becomes positive when the input is positive. So this is same thing as x is greater than 0. So the domain is all positive real numbers. Okay. Number 17, another domain problem. So gx is equal to 4 minus 6 log of base 5 of x over 6 minus 8. So basically 4 minus part is okay for any x. And we pay attention to the inside of the log function. And we want the inside of the log function to be positive. Let's multiply both sides of the equation by 6. So x minus 48 must be greater than 0. So the domain would be bigger than any number bigger than 48. Another domain problem, number 18. So gx is equal to natural log of 1 over x plus 5. And this is, so the domain must satisfy the following inequality. 1 over x plus 5 must be positive. To solve this inequality, this is from chapter 4, rational functions. So it's kind of easy to see that consider this as 1 divided by some factor in the domain, denominator, and that changes the sign at -5 only. Any number greater than -5 gonna give this expression to be positive, and after -5, because the multiplicity is odd, it's gonna be negative. So any number greater than -5 satisfies this inequality. So it's gonna be x is greater than -5, or in the interval notation, -5 through infinity. Okay, number 19. Fx is equal to log of base 7 of x plus 4 over x. Again, the domain is any number that makes this positive. So the domain is any real number satisfying this inequality. So again, this is from chapter 4. Let's say that you have a function like this. This change signs at x is equal to -4 and at x is equal to 0. If you plug in any number greater than 0, it's clearly positive divided by positive. So it's going to be positive. At x, you're going to change the sign. And at -4, you're going to change the sign. So this inequality is true when x is less than -4 or greater than 0. So the answer is -infinity through -4, union 0 through infinity. Okay. Next one, mixed problem. Fx is equal to 4 times square root of ln of x over 2. To think about the domain of this function, you need to be aware there is restriction for log function, and also there's restriction on the square root function. So first restriction, the log. Any number inside the log function must be positive. The second restriction is inside the square root must be greater than or equal to 0. Okay, so x must satisfy both of these conditions. This one means x must be positive. This one means because ln is a log of base e, which is greater than 1, so this function is an increasing function, looks like this. Okay, and if you rewrite this one by putting both sides of the inequality on top of e like this, it doesn't change the direction of the inequality sign, and you want to get x over 2 must be greater than or equal to 1. Okay, or if you graph it, you know that when x is 2, it is 0. And if you plug in any number greater than 2, it's going to be positive. So you know that x must be greater than or equal to 2. Since these two are conjuncted by and, so let's see. One of the restriction is x is greater than 0. Another one is x is greater than or equal to 2. So the answer would be 2 or higher. Okay, now this is checking a basic log function. Let's see which one. This is matching problem. The graph of a logarithm function is given. Select a function for each graph from the given option. So let's do this one together. First of all, let's take a look at this one. So this function is a log of base 9 of x, which is shifted horizontally by 1 unit. So the vertical asymptote of the log function is originally on the y-axis, but it moved 1 to the right. So I'm looking for a function with a vertical asymptote at 1. So 66 looks good. This is not, 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 this is good. And looking at the direction is, this is clearly the correct one, this is not correct. So this should go here. Okay, next one. Let's take a look at easy ones. So this is a basic one. This is a basic one. So it's going to be log of base 9 of x. So it should have a x-intercept is equal to 1. Okay, so the basic log function have an x-intercept at 1. So I'm going to looking for the graph in this direction with y-axis as a vertical asymptote and x-intercept is equal to 1. So looking at this direction, the choices are either 71 or 69, but the 71 has x-intercept at 9 or 8, while this one has x-intercept at 1, right? So this one should goes through here. Okay, I don't want to have many negatives, so I'm going to go with this. So this one is a log function, same thing as 69, but shifting 1 unit downward. So again, 71 seems to be the best choice. This is it. Yeah, so shift 1 down. Okay, now let's deal with negative numbers. So this one has, this is a reflected version of the basic log function in horizontally. So it's flipped this way. So looking at the choices, it looks like this way. So the only choice we have here is this. This one is the only one with a correct orientation. So this is gonna be here. Yeah. Okay. Now this one is multiplied negative in front. So it's gonna flip vertically. So it's like this way. So the graph looks like this direction. Looking at the choices, there are 2 cases, number 70 and number 68. Which one looks good? So the x-intercept should be 1 even when you reflect it. So 68 is not, 70 is yes. So looking at x-intercept, 70 is the best choice. Okay, 3 more things to check. Okay, so this one is similar to number 70, but you are moving 1 upward. Okay, so you have a basic log function multiplied by -1 to get this, and you're gonna add 1 to kind of move up 1. So 68 should be this one. Okay, 2 more. Let's work with this one. So this one is, so logo baseline of x is this. You change x by -x, so it's gonna have a horizontal reflection. Then you're gonna have negative in front of this, and so this is gonna flip it with respect to x-axis, so it's gonna be like this. So which is number 67. Okay, and the last one, it has a horizontal shift by 1, x is flipped by negatives, so you have a vertical asymptote at 1, and so this looks like correct one. Yeah. Okay. Okay, now kind of long question. Okay, number 22. So let's say we have a function fx is equal to ln of x plus 5. So ln of x is a basic function, looks like this, and you shift 5 upward. So the graph gonna be looks like this. So usually in the regular standard form, it has x-intercept at 1, but because it's moved up by 5 units, it's gonna go through 1, 5. Okay, and at e, ln of e is equal to 1. So at e, it's gonna be 6. The vertical asymptote doesn't change its position. So the graph is something looks like this. Okay. Now looking at the graph, it could take any values for y. So the range is -infinity to infinity. Well, I should go through in here. So domain is 0 through infinity. Domain is 0 through infinity. Yeah, this must be positive. So domain is 0 through infinity. Okay, range is -infinity to infinity. It includes every possible values here. Okay. Now the vertical asymptote is x is equal to 0, or you can say y-axis. Now, part from D, E, F is to find the inverse. So let's find the inverse of the exponential function. So you have y is equal to ln x plus 5, and whose inverse is the inverse of it is when you find inverse, you flip x and y. So swapping them, x is equal to ln of y plus 5. You are going to solve for y. Bring 5 to the other side of the equation. X minus 5 is equal to ln y. Put both sides of the equation on top of e. So it's going to be e to the x minus 5 is equal to e to the ln y, which is y. So the inverse function's output is this. So the inverse function looks like this. Okay. Now, inverse function is just basically you flip x and y. So the domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the inverse function. And that's going to answer part E. And part F is graphing. So the graphing, you can just directly looking at this function, which is exponential function, but moving 5 to the right. So originally its y-intercept is 1, because it's moved 5 units to the right, it goes through 5, 1. So looking at the choices, the choice C seems to be the best. It goes through 5, 1. The other seems not. So by looking at the intercept or the position that is moved by, from the intercept, kind of tell us which one is the correct answer. The graph of the inverse, by the way, must be symmetric with respect to the line y is equal to x. So the graph looks like this. Okay. Okay, number 23. So number 23 is f of x is equal to log x minus 1 plus 3. So let's graph this one. So this is the log of base 10. Yeah, when the log has no basis written, that means the base is 10. The domain is any number greater than 1. Domain is 1 greater than 1. So they're going to be a vertical asymptote at x is equal to 1. And when x is equal to 2, the log of 1 is 0, so it's going to be 3. And when x is, for example, 11, this becomes 1 plus 3, which is 4. So the graph looks like this. And although it's going up very, very slowly, but the range is all real numbers. Now let's find its inverse. The inverse is you flip x and y, so it's going to be x is equal to log of x minus 1, oh no, y minus 1 plus 3. Solve for y. Move 3 to the other side of the equation. Put both sides of the equation on top of 10 to eliminate log. And add 1 to the both sides of the equation. So that's going to be the inverse function. So the inverse function, y is equal to 10 to the power of x minus 3 has a following domain. Domain is negative infinity to infinity. Range is 1 through infinity. And instead of vertical, because you flip x and y, you want to have a horizontal asymptote, y is equal to 1. Yeah. Oh, I forgot to add 1 here. Yeah, okay, plus 1. So that should be able to answer everything here, okay? Okay, another similar question. Number 24. So I'm gonna go quickly. So let's say we have a function, fx is equal to 5 plus log of base 4 of x plus 4. Okay, now domain of this function is any number greater than -4. Okay, looking at this, so it has a horizontal shift by -4. So here's a vertical asymptote. And when x, so try to put number here so that the inside of the log become a friend of 4, which is 4, 1, 4, 16, and so on. So when x is -3, it's going to be 5. When x is -3, it is 5. And when x is 0, it's going to be log 4, 4, which is equal to 1. So it's 1 plus 5 is 6. And these 2 points are suffice to draw the log like this. Range is -infinity to infinity, and there's a vertical asymptote at x is equal to -4. Let's find the inverse. So the inverse is swap x and y. So it's going to be x is equal to 5 plus log of base 4 of y plus 4. First of all, move 5 to the other side. And we express this log expression into exponential. So 4 to the power of x minus 5 is equal to y plus 4. So the inverse function is 4 to the power of x minus 5 minus 4. Okay. And so inverse function is 4 to the power of x minus 5 minus 4. Domain is -infinity to positive infinity. Range is -4 through infinity. And the horizontal asymptote will be y is equal to -4. And the graph looks like, okay, graph looks like this. So the original function has -3, 5. So the inverse function should have 5, -3. Yeah, 5, -3, and 6, 0, 6, 0, 6, 0. So the graph looks like this. Okay, and they are symmetric with respect to the line y is equal to x. Okay. What? Oh. Okay, so that's complete explanation for section 5.4. Thank you very much.